Today we're going to work on a review of transformations. We've been working on transformations for a couple weeks, and we've gone through a bunch of information that we need to review for your unit test this week. First thing I want you to do while watching this video is take notes. Use your graphic organizer to write down as many things as you possibly can about each transformation. Second thing I want you to do is write down the vocabulary. Write down the words that you know, write down the words that you don't know. Third thing is to do the examples on the back of your graphic organizer where you have 4 coordinate grids to work with. Fill in as much information as you possibly can. Pause the video at any time, rewind it, or replay something if you've missed it. We're going to collaborate at the end, put together all of your information with your classmates' information in case you've missed something. So here we have each of the 4 transformations that we've done over this past couple weeks. The first one that we have is a translation. It takes one object and slides it over, right, left, up, or down. The second one that we have is a reflection. A reflection flips an object, and it's a mirror image of the pre-image. The next one that we have is a rotation. You can rotate things 90 degrees, 180 degrees, and 270 degrees. You can rotate them also clockwise and counterclockwise. And the last one that we just talked about was a dilation. A dilation shrinks or enlarges an object by a scale factor. If the scale factor is a fraction, the object will shrink. If the scale factor is a whole number, then the object will be enlarged. So our first one that we're going to work with is called a reflection. We are going to graph the rectangle LATR with vertices L00, A50, T53, and R03. We will reflect the rectangle over the x-axis, graph the image, and write the rule for such a reflection. We will label the image L', A', T', R'. Now that I've read the question, I'm going to go back through and highlight some things that are important. So I've highlighted the coordinates, I've highlighted the transformation that we're doing, which is a reflection. We are going over the x-axis, so I'm going to mark that we're using the x-axis. I need to graph and write the rule, and I need to label the image. So here I have the rectangle LATR graphed on my coordinate grid, and what I'm going to do is switch colors to show you a reflection over the x-axis. Since L and A are on the x-axis, they really don't have anywhere to flip to. However, R and T are going to reflect over and be new coordinates. So let's check to make sure that we've done everything that the question is asking us to do. We graphed LATR, the original rectangle. We reflected it over the x-axis. We graphed the new image. We haven't written the rule yet. However, we have labeled L', A', T', R'. Notice how the two figures are the same shape and the same size. That has not changed at all. So let's look at the coordinates, the original coordinates of R. R was at 0, 3, and now R' is at 0, -3. So it appears that the rule is that we started with an XY coordinate, and all that changed was the YB coordinate became negative after reflection over the x-axis. Let's now go through how to do a dilation. We are going to graph triangle ABC with vertices A, -2, -2, B, 1, -1, and C, 0, 2. Let's dilate the figure with a scale factor of 2 and label the new figure triangle A', B', C'. Here we go. So each of the coordinates are going to be multiplied by a scale factor of 2. So that means that the x-coordinates multiplied by 2 and the y-coordinates multiplied by 2. For A, I get -4, -4, or A' rather. For B', I get 2, -2. And for C', 0 times 2 is still 0, and 2 times 2 is 4. So my new triangle, A', B', C' looks like this. and has coordinates -4, -4, 2, -2, and 0, 4. With a scale factor of 2, I've enlarged the triangle 2 times the size. In order to do a rotation, I'm going to start with graphing the point Q at -4, +7. I'm going to label it Q. I'm going to rotate this about the origin 90 degrees clockwise. That's going to put me at +7, +4. And this gives me point Q prime. So really, with a 90-degree rotation, the XY coordinate reversed order, and the X, the sign changed. If I go 90 more degrees, I'm now at 180 from my original point Q. So instead of the point -4, 7, I'm going to have Q double prime at 4, -7. So what happened is that the X coordinate, the sign changed, and the Y coordinate, the sign changed. If I go 90 degrees more, I'm at 270 degrees from the original Q at -4, -4, +7. So what happens if I rotate this Q double prime 90 degrees more? Well, that's going to put me at -7, -4, which means that I reverse the order of the coordinates, and so the Y comes first with a new sign, and the X comes last, and the sign stays the same. So our fourth and final transformation is a translation. We are going to graph the point J as 5, 8. We are going to translate the points 3 units left and 10 units down. We're going to plot the image as J prime and write its coordinates. And finally, we will write the translation notation for this example. So here I've gone from the origin over 5 and up 8, and this is point J. From point J, we are going to count 3 units to the left, and we are going to count 10 units down, which puts us right here. We're going to label it J prime, and we're going to write the coordinates. The coordinates are 2, -2. The last thing the question is asking us to do is to write the translation notation. That means, what have we done to X and Y? Well, in the past, we said that if you are moving left, we think about a number line. We're going in a negative direction. If you are moving down, same type of thing. You're moving down the number line. You're going in a negative direction. So really, for the X coordinate, we are taking away 3, and for the Y coordinate, we're taking away 10. There's our translation notation.